Welcome back to Mr. Hassan's Maths channel. I'm answering question number 13 from the June 2022 IGCSE Cambridge Paper 2, Variant 1. This is from the 0580 paper. Now this question here is about calculations involving standard form. Now this question here is actually a very important question because when I teach this topic, many students they just say, what's the point of explaining how to do this when we can just stick this in our calculator and get the answer? And, many of the mark schemes, they don't really mention any steps and stuff. And, if you put this in your calculator, you'll get the answer. And, the students feel they'll get the full marks. I always tell them you should know what is behind it, how to do this. One, you might end up with algebraic problems, or two, you might end up with problems which your calculator can't handle. Now, this is a case, if you look at this question here, the calculator can't handle these values. If I put 2 times 10 to the power of 100 in my calculator, it can't handle it. It says math error. Okay, because it's too big. If I put, for example, 2 times 10 to the power of 10, okay, it can handle that. All right, or 2 times 10 to the power of 5, it will give me an answer. But if I put 2 to the 10 to the power of 100, it's too big for the calculator to handle this number, and it just says math error. So if I put this in my calculator the way it looks like here, minus 2 times 10 to the power of 98, it's just going to give me math error. So there's no way you can just do this using your calculator. You have to understand how to do it. Okay, as I keep stressing to my students, and many students ignore that because they think, oh, we'll just put it in the calculator, it doesn't matter, we don't have to worry about this. But you do. And this question illustrates that you do have to worry about it. Okay, so that's where you should try to understand what to do. Now, when you're multiplying, when you're subtracting and adding numbers in standard form, when you're adding and subtracting numbers in standard form, okay, think about what you're actually doing when you're adding and subtracting numbers. You are adding numbers, for example, if I'm adding, for example, 2,756 and 384, I'm adding the numbers which are in the same position, place values. So I'm adding the units with the units, the tens with the tens, the hundreds with the hundreds, the thousands with the thousands, and so on, and then I can proceed. So here I can't, like, for example, say this is like 2 minus 2, because these twos are not, they don't have the same place value. This 2 has 100 zeros after it. This 2 has 98 zeros after it. So they don't have the same place value. So I have to express them in such a way that when I subtract or add, in this case subtract, they have to have the same number of zeros after them. They must be representing the numbers which have the same place value. Okay, so what I've got to do here is I've got to change these so that they're the same. So I either change this to 10 to the power of 98 or I change this to 10 to the power of 100. Now, you'll notice, as I mentioned and when I'm teaching in the classes, that it's always best to change the one with the lower power and make it into the higher power, because that will give you your answer in the quickest way. Your answer will then be generally in standard form in the end. You won't have to mess around with the answer. So I'm going to change this. I'm going to say 2 times 10 to the power of 98. I'm going to express it as something times 10 to the power of 100. Okay, so I've got to think to myself, how does that become something times 10 to the power of 100? Well, to make this 10 to the power of 100, I have to multiply it by 100. 10 squared, right? That will become 10 to the power of 100. But because I want this number to be the same as this number, I want them to be exactly the same, I have to do something to this that balances out what I did there. So if I multiply this part by 100, I should divide that part by 100. Okay, then it's like I haven't changed the value of it. But if I divide 2 by 100, I'm going to get 0.02. Now 0.02 is equal times 10 to the power of 100 is the same value as 2 times 10 to the power of 98. Now I can take my original number, 2 times 10 to the power of 100, subtract this in this form. Now these two numbers can be subtracted because what's after this 2, okay, is 100 zeros, and what's after this point here is 100, 100 places basically. So the 2 is in the units, the 0 is in the units. This is in the tenths. You have 0 tenths and you have 0 hundredths. So I can just subtract 2 minus 0.02, and that gives me 1.98. So I know when I subtract these numbers, I'll have 2 minus 0.02, and my answer is going to be times 10 to the power of 100. So I end up with 1.98 times 10 to the power of 100. So it's a very, very important question here, which, as I said, many students ignore this because they think I'll just put it in my calculator. But as you can see, the calculator will not give you the answer because the numbers are too big to handle for the calculator. So this question forces you to understand this, it's very important that you do listen to what your teachers tell you and don't think, oh, I'll just use a calculator, just ignore it, it's not important what it's saying, because you might end up with a question like this and then you'll regret it. All right, so please make sure that you understand. So what we did here is when you're adding or subtracting numbers in standard form and you see that they're not expressed with the same power of 10, you have to make those powers of 10 the same. Okay, and it's always going to make it easier for you to make the power which is lower into one that's bigger. So this becomes 10 to the power of 100, which means I had to multiply it by 100, because 98 times 10 to the power of 98 times 10 to the power of 2 gives me 10 to the power of 100. So therefore I had to divide that part by 100, so that gives me 0.02, and then I can subtract those numbers, and everything will be correct in terms of the place values, and my answer will be times 10 to the power of 100, and that's it. Okay, so there's an answer to question number 13 from this paper. Very, very important question. Other questions from this paper, when I get to do them, will be in the playlist over here. Other questions from the topic of standard form and calculations involving standard form will be in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon. And any other questions that you want to ask from these papers that you don't see in the playlists, please do send me a comment and I'll answer those questions as soon as I possibly can. Thank you for watching and see you soon.